Hello, everyone, and welcome to yet another episode of Beyond the Job Title. Today, we have with us Vaibhav Gupta, who works as a hardware engineer. Welcome, Vaibhav, to the show.
Thanks a lot, Manmeet, for inviting me to your show and giving me this opportunity to share my knowledge and experience with our audience. Thank you very much.
Sure, thanks. So, a very quick note to the audience. Today, we also have something special. Vaibhav will be presenting us a case study, which will give some real life insights on what the role involves and learnings from which can be used by the viewers, whoever are aspiring to become hardware engineers. So, Vaibhav, first and foremost, could you give us an overview of what your role is all about?
So basically, currently, I am a graphics hardware engineer at Intel, and my role basically involves validating the latest graphics processing units or GPUs, which are designed by Intel.
Okay.
So I'm in the GPU validation team. So my primary role is to validate the whole GPU hardware. Basically, we call it IP. So at the IP level, I do the validation if the design is working as per the specifications. So that is my main role. And along with that, I also support other teams uh, like the system on chip team and the driver team, which is basically low level software team.
Hmm.
Or so that team basically the SOC team basically integrates our GPU IP into their SOC, which is system on chip.
Okay.
So our GPU, our graphics processing unit, is one of the IPs in the SOC. So when the SOC team integrates our IP in their system on chip, then they also validate the whole system on chip as a whole. So if there is some failure which is occurring in the GPU IP, right,
So, what
or
does
they
IP
suspect.
stand for? So, SOC
So
is system on
IP,
chip, and IP stands for?
so IP is basically intellectual property.
All right. Okay.
Yes.
Okay.
So I support the SOC team also, and then I support the driver team. So basically, what the driver team does is they have some low-level software
Mm,
which they try to run on the on our design hardware. But
mm,
this is still on the pre-silicon level. So basically, before the chip has been fabricated or the design is sent for fabrication, right?
mm-hmm,
The
mm-hmm.
driver team takes our design, which is coded in a hardware description language, which is basically system bedrock. I think some of the viewers might be familiar with it.
Mm-hmm.
So, so basically, the driver team runs some low-level software on our hardware design, and find they see whether the design is working as expected or the design has some failures. It's not working for certain cases or some kind of workloads.
Mm.
So I support the driver team also. So
Great.
basically, that's my role, the overview of my role.
Great. Thanks, Vaibhav, for sharing that. So, Vaibhav, if I have to ask you, what steps did you take to launch yourself in this career?
So, uh, so my journey started. If you ask about my academic journey, so
Mhm.
I have a bachelor's in electrical engineering from IIT Kharagpur, and after that I applied for higher studies in the US. So basically, master's and PhD program, integrated master's and PhD program. So I had uh, a master's in electrical and computer engineering from Purdue. And after that, I started my first job as again a verification engineer, basic verification engineer at Cisco.
Mm-hmm.
So I worked there for about 3 years. And at that time, I was not very sure if I would like to continue in this role in the long term.
Mm-hmm.
So what I did was I took a break from the industry and I again entered academia. I applied for another master's plus PhD program in applied mathematics. So I was accepted to University of California, Merced, and there I spent another about 2.5 years doing my master's in applied mathematics. So that gave me a more wider skill set and some additional tools from applied mathematics, which I would be able to use in my job. So that was my motivation. And after I finished my second master's, I again started applying for jobs, and I got a job at Intel in the GPU validation team, where I am currently. So that's my journey.
Sure, understand. So this GPU verification, is it very similar to what you did earlier at Cisco, or is it slightly different?
It's not exactly similar. So at Cisco, I was mostly doing verification at the block level, or at most at the subsystem level.
Mm.
So there also at Cisco, we had a system on chip, but the verification I was doing there was at the block level, a very small block, or at most a collection of blocks, which we call a subsystem.
Mm.
And here in this team, uh, I think many viewers who are from the hardware background, they might be able to appreciate that the GPU is a very complex piece of hardware.
Mm-hmm.
So it consists of a lot of uh, hardware blocks and sub blocks underneath, and to verify all of that is not a simple task.
Mm.
So in the GPU itself, it contains two mini processors. So two mini processors which are similar to the CPU, or the central processing unit, and in addition to that, you have a bunch of other hardware blocks which basically implement the 3D graphics
Mm-hmm.
functionality, which is used which which is used by Microsoft and other vendors, right? The 3D graphics functionality and the APIs are supplied by Microsoft and other vendors, and that's what runs on the GPU hardware. So this task is a little bit different, and the set of tools used is also different. So at Cisco, I was using mostly System Verilog, very little bit of C++, and some scripting.
Mm-hmm.
But here in this role, I'm using mostly C++ and a lot of scripting, and very little System Verilog, because my job is to validate at the IP level. So basically, the IP mostly interacts with the software or the host,
Mm-hmm.
which is the CPU. So the host software runs on the CPU, and it submits jobs to the GPU, which we call workload.
Mm-hmm.
So the validation process is basically ensuring that whatever kind of workload the CPU submits on the GPU, that is working as expected, and the GPU is able to uh, work as per the functionality and produce the correct output. So that's
Sure.
how this current role is different.
Sure. So all very technical. So my next question is, if
Mhm.
somebody wants to enter into this field, what could be a potential career path? Though hearing about it, it sounds very technical, and I think definitely it is not a piece of cake like somebody might study online and can get into it. But could you
Yes.
possibly chart a pathway for someone if somebody is interested? What could be a potential a series of steps they can take to become
Yes.
a hardware
So
engineer?
first of all, since this is a role which requires both hardware and some software background,
Mm,
so it is very important to have at least a basic degree in either hardware or software. So basically, either electrical or electronics
mhm,
uh, engineering or computer engineering. So
mm,
that should be, if you have that degree, then you are already way ahead on this path. So that is the basic requirement. And once you have that, obviously you need to have a very good knowledge of hardware design and also some basic programming skills like system Verilog. So that
Mm.
system Verilog is a hardware description language which is used to basically design hardware. That's the language in which the design of the hardware is specified. So you need to have some system Verilog skills. Then you need to have some basic programming skills in C++.
Mhm.
You also need to have some scripting skills, such as the knowledge of Perl and
Mhm.
Python. So, so basically, you need to have a wide variety of skills to excel in this kind of job.
Mhm.
And even entry in this kind of job will require you to have knowledge of preferably all these, or at least little knowledge of all these tools and languages, and maybe expertise in one or two of them. So there are also some online courses and MOOCs.
What
Uh,
are MOCs?
so MOOCs is basically massively open online course. So like you have Coursera, Udacity, Udemy.
Mm.
So
Mm.
these kind of MOOCs applications, right, or companies which host MOOCs, they also offer a lot of online courses, and some of which are relevant for this kind of role, like hardware design, hardware validation, system Verilog, verification validation, and then C, C++, Perl, Python. Those are very common anyway. So people can develop those skills using those MOOCs, online courses also.
Mm.
And then you can also attend industrial workshops and conferences
Mm.
if you get the opportunity to learn what is the current trend in industry and what other companies and other uh, senior technical leaders are currently working on. So that also enhances your knowledge and skill set. So that also will be definitely very helpful in entering this domain.
Are there any potential internships or any, uh, I would say, self-managed projects that someone can pick to gain understanding?
Yes, definitely. I mean, as I mentioned, these MOOCs are there, right?
Mhm.
A lot of those courses, even I have done one or two of them. So they also have a small toy project. Like it's not a big industrial scale project, but it's a toy project, which basically you can do sitting at home on on a public server provided by them, where
Mhm.
you can run small toy code and see things working in real time and
Mhm.
make sure that you get some hands-on industrial experience or at a small scale. So those definitely people should do. Anyone who's aspiring to enter into this kind of role. So that will be definitely very helpful. And then the industrial workshops and conferences also sometimes in their tutorial sessions, they have like a toy project which can be done in like an hour or two. So doing that also will be definitely very helpful.
Sure. Thanks, Vaibhav, for sharing that. So moving on, could you describe what a typical day in your shoes looks like? How does your
Mhm.
workday start? What are the tasks, activities you do on a typical day?
Right. So basically, my day starts first of all by checking my inbox,
Mm-hmm.
which is I think common for a lot of us in the industry. So I start checking emails, and then obviously sometimes there are a lot of emails and the tasks. There are a lot of tasks on my plate, so I have to start prioritizing them first based on the projects which are running currently and the project timelines.
Mm.
So my day starts with that first, having a clear cut understanding of what task I need to work on first and what is the next task and so on. And sometimes I have to also work on multiple tasks. depending on the priority, or if one task is running, or one task is going on, and it needs some time, or there is some other dependency on another team, I can shift to the next task while the other dependency is being met. So that's how it starts. And day-to-day tasks involves, since I am in the validation team, right?
Mm-hmm.
So we run a bunch of tests on our hardware design, and obviously getting all the tests to pass is very rare. So there are a lot of test failures in our runs, and we need to check uh, the failures, the tests which are failing, and then based on their signature, failure signature, right, we need to debug them or
Mm-hmm.
we start. So basically, debugging test failures and then filing tickets on the failures which you are debugging, right? So the
Mm-hmm.
tickets based on your debug, once you almost root cause the debug or uh, basically think that, oh, this bug could be due to this, an issue in the design or an issue in the test bench or the test itself has a bug, the test is not properly written. So based on your analysis, you basically file a ticket on that particular team, which you think might be causing that bug. So filing tickets, debugging, filing tickets, and then some time is also spent in meetings. So once you file a ticket, sometimes you have to meet with the corresponding team to discuss that failure and then really root cause if the failure is really due to a bug on their side or it's some other team. So that kind of discussion goes on. So sometimes also spent there. Actually, a lot of time is spent in meetings and discussions with other teams and coming to a resolution.
Sure, sure. Understood. So moving on, Vaibhav, could you tell what is the few things you enjoy in your work, and what are some of the challenges or things which don't enjoy that much?
Mhm. So as I already mentioned, right, the GPU is a very complex piece of hardware,
Mm-hmm.
and obviously where there is complexity, there are also opportunities for learning. So there are many opportunities to learn the hardware architecture of the GPU, the GPU hardware design in depth. And that learning happens by debugging different kinds of failures. And each failure generally has a different kind of root cause. So
Mm-hmm.
basically, the point of starting the failure debug and the point of reaching the root cause, right? Along the way, there is a lot of learning which happens both on the software side and the hardware side based on where the root cause of the bug is. So that's something which I like, the learning part. And other than that, there are also many opportunities to make the debugging more efficient
Mm-hmm.
and faster. So because the GPU is very complex, so any the test which runs on it also takes a lot of time. Sometimes maybe many hours or even a day or a couple of days. So and obviously the debugging part is also very time consuming. So there are a lot of opportunities to innovate to make the debugging or root causing the bug faster. And you can develop a lot of techniques to do that by automation or scripting or even using like these days AI is the buzzword in the industry, right?
Mm-hmm.
So there are a lot of applications of AI being done everywhere. So in this kind of role also, you can use AI to make the debugging more efficient and faster. So that is something which I get excited about, those opportunities. And if we talk about the challenging part, right?
Mm-hmm.
So this is since I am in the GPU IP validation team, so and I have to interact with a lot of other teams also. So there is a lot of coordination involved with other teams, and often they are located in different geographies. Like I interact a lot with the team in India, in Bangalore. So sometimes this coordination takes a lot of time, or it gets delayed because of the different time zones between US and India,
Mm-hmm.
or different geographies wherever your team is situated, right?
Mm-hmm.
So that is sometimes very time consuming, and that introduces significant amount of delays in coming to a resolution for a particular failure. That is one challenge I can think of. And sometimes the other teams have different priorities. The project priorities are different. So the project which you are working on might not be as important for the other team, because they are already ahead, looking ahead in the next project, working, right? So that is sometimes is a challenge. Delays get introduced due to that also. So yeah, those are the
Sure.
pros and cons.
In terms of the skill sets needed to excel in this role, what do you think are the skills needed?
So I already discussed before. So the skills basically, you need to have a very solid understanding of computer architecture. So the
Mm,
basics of computer architecture and the basics of hardware design,
mm,
and then some programming skills also, like system Verilog, C++, scripting like Perl and Python, uh, scripting languages. Those skills definitely are required in this role. And apart from that, if you have computer science background, like some kind of background on, let's say, 3D graphics,
mm,
3D graphics functionality, and maybe even machine learning, deep learning, some kind of data science background, if you have, that also will be definitely very helpful, because then you'll know when a particular test or workload is being executed on the GPU. You'll know from the beginning what that workload is supposed to do, and that can help you in your debugging process. So yeah, so there are some skills which are absolutely needed, like computer architecture and some basic programming and scripting skills. And apart from that, if you have the application knowledge also, like 3D graphics or machine learning, deep learning, then that will be really good for this role.
sure, sure. Thanks. So, Vaibhav, is there a piece of advice which you recollect, which was
Mhm.
given to you and has greatly helped in your career journey so far?
Yeah. So one advice. So I also keep attending some career development workshops in
Mm,
Intel. Uh, I'm sure other companies also organize such workshops. So I remember one of the leaders in our organization in such a career development workshop, one of the workshops he was saying, and that struck me actually. So he was saying that people generally focus on individual success, like
mm,
they want to get their work done like efficiently and make sure their work is done, and they don't think about the whole big picture of the picture, the picture of the team from the team perspective, right?
mm,
So so the advice he gave was that you can focus on individual success. That is good. I mean, it's good to focus on individual success, and it might even help you in the short term.
mm,
But in the long term, there are more chances that it will hurt you, because ultimately your success is dependent on the team success and the company's success, right? So if the company is successful, obviously it will have more opportunities for your team, and only
mm,
then you will have more opportunities for contribution at the individual level. So basically, we should try to focus not just on individual success, but we should also keep the global bigger perspective in mind, from the team's point of view, or even the organization point of view, and even going higher, right? The whole
mm,
company point of view. So if you focus on that bigger picture, have that kind of vision,
mm,
that bigger vision, right? And work towards it, align your tasks and goals in that perspective, right? That should be very helpful in your career in the long term. That is.
Sure. So, Vaibhav, if there is one advice you would like to give viewers, what would
Mhm.
that be, which can help them in their career journeys?
I mean, based on my personal experience, I would. Uh, so basically, what I would like to advise is people or professionals, young professionals who are aspiring to excel in this kind of role and this kind of, or even enter this kind of job, right?
Hmm.
They should focus on building very solid fundamental skills, because in the end, it's the skills which matter. Like you
Hmm.
can, there are different kind of roles, right? But the skills, the basic skills, the basics basically of, let's say, hardware design, computer architecture, programming skills,
Hmm.
those you should make sure that uh, you have a very basic, very good command on them. So so aspiring professionals or job seekers should spend like as much time uh, as possible on mastering these basic fundamentals,
Hmm.
because if the foundation is strong, only then you can build a good building on that. So that is the advice I would like to give.
Sure. Thanks, Vaibhav. So, Vaibhav, in terms of the growth opportunities in this role and
Mhm.
future prospects, what do you think are the growth opportunities?
So as I was discussing previously, before also, right, these days AI is the buzzword in the
Mm,
industry. and and GPUs, graphics processing units, are one of the key pieces of hardware, right, on which different AI applications are run, like machine learning and deep learning workloads from different domains. They run
mm,
ultimately on the GPU, and a few of them on some accelerators. But GPU is still one of the key components in the AI era, so to say. So obviously, there are a lot of opportunities in the field of GPU design and validation, and you have opportunities both in the hardware and software areas. So on the hardware side, you can work on different efficient architectures like high performance architectures, low power architectures, hardware architectures for uh, new machine learning and deep learning models and algorithms, right? So there are opportunities there. And on the software side, similarly, you also have opportunities to develop efficient, high performance, and low power software, which can run on these efficient hardware architectures.
mm,
So that is in the on the development and design side. And as the complexity of the hardware grows, obviously, uh, you need uh, more efficient techniques for validation also, and more uh, areas of automation and uh, machine learning, application of machine learning and AI to validate the newer designs, to find out bugs faster, to isolate them, to bucketize them. So there are a lot of opportunities, and as long as the AI uh, applications will keep growing and the field of AI keeps growing, uh, this growth in this area will also follow, because it is closely connected. Ultimately, the growth of AI depends on how well these hardware architectures are designed and how well the software is written to get the result faster. So
mm.
definitely there is a lot of opportunity for growth in this area.
Nice. Coming to the last question of this podcast, Weber, what is work-life balance like in your role?
So I mean, work-wise, Intel, uh, according to me, is a very good company. I mean, the work-life balance is pretty good. Obviously, it also depends on your team. But overall, I find a good work-life balance working at Inter. And the office timings are not very strict. There is a lot of flexibility, although the official work hours are 8 to 5. I mean, I'm sure this is mm, applicable to most of the companies out there. I mean, 8 to 5 or 9 to 6. I mean, these are the official hours, but obviously you have some flexibility depending on your team and manager to work little bit like off time, like you can work like as per your convenience based on your team culture and manager, right? And obviously, um, we had COVID recently, so there many companies introduced uh,
Remote
uh,
working.
remote working and work from
Mm-hmm.
home facilities, right?
Mm-hmm.
So, so that makes that again introduced more flexibility, right? So, especially people who have families like me and you also, they if there is more flexibility, obviously it makes life somewhat easier. And the key thing is basically to manage your time, day-to-day time properly. So
Mm-hmm.
I basically try to have a well-planned and structured day. And as they say, those who fail to plan to fail.
Mm-hmm.
So planning is key, basically, to have a good work-life balance. You should have uh, a well-structured day. You need to know what time you need to do what task. You should have that clarity. And I make sure I have sufficient time for my family. And I don't try to overwork or unnecessarily burden myself if some task is not complete on a particular day. So I just take it easy and wait for the next day to complete it. And oftentimes, what happens is if if you are working on a task for a long time, right, and you are going
Mm-hmm.
nowhere, you're not finding a solution. When you just leave that task, you just do some completely different activity, like talking with your family or going out for
Mm-hmm.
some walk or jog or run or somewhere, right? Suddenly, the solution to that problem which you have been working on for a long time, that suddenly comes up from nowhere. So some some people call that intuition.
Mm-hmm.
So so that also I feel that people should not unnecessarily burden themselves because your body and mind also needs proper rest. So you need to have proper day to day, day and night routine, a good night's sleep, and
Mm-hmm.
a good regime, exercise regime also. So definitely, if unless your body and mind is healthy, you'll not be able to be productive in your work. So that's how I try to organize my day uh, so that I have time. I have time for sufficient time for recharging and rejuvenating.
Sure. Thanks, Vaibhav. And now coming to the interesting bit, a real
Okay,
life case study of seeing hardware engineering in action. So
sure,
can you please share that case study, what it was, what was the situation, problem?
sure. So so this uh, there were so this problem which happened uh, was I think when I joined. I think after I joined this team, when I initially joined this team, I was told to work on some support for the SoC team, the system on chip team, right?
Mm-hmm.
So they used to take our GPU design and integrate that design in their system on chip, and then they used to run tests
Mm-hmm.
on them.
Mm-hmm.
And then, as I discussed before, also, right, if they found some failure, some test which is failing, not working as per the functionality,
Mm-hmm.
uh, and if they suspected that the problem lies inside the GPU,
Mm-hmm.
then they came to our team for resolution.
Yeah.
And obviously, the GPU itself is very complex. And when that gets integrated into the system on chip or SoC,
Mm.
the system on chip design is even more complex. So, so the tests which you run at the system on chip level, they take even longer than the tests run at the GPU level.
Mm-hmm.
So obviously, the debugging time, the turnaround time for root causing a debug at the SoC level also increases. So, so in our case, right, in my case,
Mm.
so that when the SoC team used to come to us for resolutions on failures, right? So after you run a test, you have uh, a kind of file which gets generated, which is of the order of like gigabytes, like hundreds of gigabytes, or sometimes even more.
Mm-hmm.
So basically, there is a tool in our workflow which we use to open that file, and that helps in our debug. And in my case, right, when I initially started doing that kind of job, that kind of support for the SOC team,
Mm-hmm.
I found that whenever the file size is huge, right, hundreds of
Mm.
GBs, just to open that file in our tool, which we used to in
Mm.
our workflow, right, just to open that file and start analyzing, that itself took like 2 hours, 2 to 3 hours.
Mm.
And then once you open that file, you have to start analyzing from the point of the failure, right? You get an error message in a failure, and you start from there. And then you start analyzing the different signals inside the hardware using that tool
Mm-hmm.
and that file. So just opening the file was taking 2 to 3 hours. And only after that, you can start your analysis and start working on the root cause of the failure.
Mm-hmm.
So I thought that, I mean, if we spend just 2 to 3 hours just opening the file, I mean, that time is definitely a big waste.
Non-productive, yeah.
And that needs, and definitely we should try to have a search for solutions to overcome
Mm.
this
Mm-hmm.
uh, opening time, file opening time of the order of hours, right? So, I mean, I obviously there are a lot of tools supplied by different vendors in our team. Like if people know that Synopsys is a well-known software company
Yeah. Yeah.
which supplies various software tools for hardware design and validation.
Mm.
So and ironically, that tool which was used to open that failure file, right?
Mm-hmm.
That was also provided by Synopsys. And along with that, there is also a tool, and that tool was that initial tool which we used to open files that was based on a GUI. It was a graphical user interface.
Mm-hmm.
And along with that, Synopsys also provided a programming interface to open that kind of file, which no one was using in our team.
Okay.
And but I found that I someday I was just going through the documentation,
Mm.
and I found like some use cases for that programming interface,
Mm.
and they had some toy examples on that also. I started running them and seeing if it even works.
Mm.
So I found that it's really working, and s- although that was a toy example, I thought let's try it out on the big huge file which the SOC team gives us.
Mm.
So basically, to analyze the signals on that failure file, instead of using that graphical user interface, which takes like 2 to 3 hours just to open that file,
Mm.
when I use that programming interface, right, to open that file and analyze the signals, that that actually took seconds, literally,
Wow.
or
Okay.
at most 1 or 2 minutes.
Mm.
So, I mean, I had to read a lot of documentation and take help from some external teams also, the tools team, basically,
Mm.
which manages those Synopsys tools, uh,
Mm.
to make that tool integrate that programming interface in our debugging flow, right? So, but I was able to do that uh, after some uh, hard work there, and I was able to accelerate at least the opening of that file. And fortunately, that programming interface also had other APIs
Mm.
uh, to basically probe the signal level details inside that failure file, which could be further used to further accelerate your debug process.
Debug process. Yeah.
Yes. So that actually improved our efficiency, at least the debug turnaround time, definitely. So that was a major improvement in our
Yeah, it also
throughput.
helps in the working, right? Not only improves the
Exactly.
debug time, but
I
also.
mean, yeah, you need to, and fortunately that programming interface had the option of C++ or Tickle.
Mm.
If the audience might have, some of the audience might have heard of Tickle or TCL.
Oh, okay.
Yes. So I use the C++ side of the interface because there you get to also sharpen your skills
Mm.
in C++, right? So I use the C++ interface, and you have to write a short program to basically interact with that failure file and probe the different signal level details. So I did that, and fortunately, we were able to improve our debug throughput a lot, and that also resulted in a research publication at a conference, at a local conference here in 2020. So the conference name was Snug, or
Mm.
and it was organized by Synopsys only. It is basically organized every year by Synopsys. So I was able to publish that work there in Snug, the conference. Yeah.
Very interesting. Thank you so much, Vaibhav, for coming on the show and sharing your insights. It was
My pleasure.
lovely
Thank
speaking.
you.
Thank you so much.
Thank you, Manmeet.